Good afternoon. Welcome to our video presentation. This presentation is a part of the course Vehicle Failure Analysis, where me, Bahir, and my friend Yusuf going to investigate two damaged crankshaft of single-cylinder diesel engine used in agriculture surface for several purposes. We are working under the supervision of Dr. Roman, and this presentation is a brief overview of the engine, which will include components and the working condition and finally the materials. We are not going to give a detailed analysis of the failure. So this is our plan for this presentation. Firstly, we will mention the introduction and overview investigation, and then the background of the failure. After that, we will go through to the engine working condition, what are the components and the working condition and the type of loading. Finally, we will go through the materials, what are the materials and require materials properties.
Hello guys, this is Yusuf. Well, in introduction, this paper report an investigation carried out on two damaged crankshaft of single-cylinder diesel engine used in agricultural surface of several purpose. Recount damage of this crankshaft type have happened after approximately 100 hours in a serve.
After 2 years of operating of this agriculture machine, the catastrophic failure frequently happened. When the customer complained to the commercial seller and to the mechanical workshop, the answer always was the same. It was for sure an overloading of the motor or a sudden refusal of motor operation. So our task here is to find out the actual cause of the failure.
The picture shows the actual failure that took place. We can see two crankshafts for the figure A and figure B, the crankshaft 1 and the crankshaft 2. In engine working condition, the two engines have the same specification. 9 horsepower and single-cylinder diesel engine force torque 3000 rpm and the torque 30 newton meter and the cylinder diameter 85 millimeter, torque 90 millimeter, displacement 510 and time served about 100 hours, 15 times 106 cycles.
Belong to the diesel engine used for agriculture purpose. As you can see, rule of components. This is a typical crankshaft arrangement for 4-cylinder engines, but ours is a single-cylinder engine. However, the components are the same. This is the crankshaft connected to the engine cylinder through different components. There are many components are connected to the crankshaft. What is connecting to the crankshaft? Firstly, the main journal and also the crank web, and also we got the crank throw, oil pour, crank pin, and also the counterweight. What is the counterweight doing? This counterweight is used to balance forces. And also, each pair of crank web is connected together to the two main journal. The main journal bearing support the whole crankshaft on the bed plate, and we also got two crank web making crank throw, and we have also four crank throw, so each crank throw is connecting to each separate cylinder. This whole crankshaft is connecting to the bed plate by this journal bearing, and finally this shaft is rotating by the crank webs. And who is rotating the crank webs? Cylinder, or each cylinder. So this slide for the working condition. And to begin with the question, what cylinder does? With this cylinder we have compression and compression going inside the cylinder, and that's why what happened, this cylinder is going up and down, and that's what we call it reciprocating motion, when the piston is going up and down, and this piston is connecting by the connecting rod to the crankshaft as shown in the figure. So using this arrangement we are converting or translating the reciprocating motion to the shaft as the rotating motion. This rotating motion here gives rise to a torsional force and bending force, and therefore this shaft is subjected under two kinds of forces. What are the forces? Firstly, we got the torsional loading, and secondly the bending load. Because of this reciprocating motion, the loading is a cycle load.
Hello guys again. So what we're seeing in that graph, along this process, the graph shows the force on the crankshaft at different crankshaft angle. When the crankshaft is at 0°, then the force acting in the both radial and direction are minimum, and as the angle increase, meaning starting rotating, and force get higher gradually until 270 and after that the force increase suddenly and reach the maximum 2000 Newton or 20 kilonewton at 360°. When crankshaft makes full revolution, after 360 the force decrease and reach to maximum at 72, and this process will continue like that. So again, from 0 to 360° there is one revolution and another one. From 360° to 72°, so that's two revolutions making one cycle here. There are the highest stress involved in here, as we can see in the graph, that has reached 2000 Newton. There is quite huge force, so withstand this force, this component have to be tough and strong enough. That's why this machine component have to be heat treated. So what is the materials? These the materials that are used in the machine. Forget steel, neutral cast iron, ostamabrid, dielectric iron. For required materials properties, the material has to be radially shaped machine, and it has to be properly heat treated, because we have higher stress or force involved here. It has to be strong enough. To end up the video, a brief overview of the engine and its working condition have been given. In the next presentation, we are going to analyze the failure in statistical analysis and details.
Finally, our task now would be to investigate the reason behind this video. And thank you guys for watching this video. I hope you enjoy it. And please press like and subscribe and write your comment, please. Thank you very much.